This is KG Misra. I have come with the next part of the video lecture on chapter Gravitation of class 9th. Okay. In the last video, what we have done, we have discussed about the gravitation, what is gravitation actually, and when it is called gravity, what is the expression for force of gravity, what is acceleration due to gravity, okay, and what is the value of acceleration due to gravity on the surface of Earth, and we have discussed some equations of motion. Okay, now this is time to go for some questions, numerical questions. Okay, so I'm starting with the question is that ball is there, it is thrown in the upward direction with a velocity of 25 meter per second. Initial velocity is 25 meter per second. Okay, now it is given that we can take here, it is given in the question. Okay, g is equals to 10 meter per second square. Okay, what you have to find out, you have to find out the maximum height it will attain. Okay, and the total time it will take to go up and come back to its place. Okay, now see, whenever we throw something, what happens, it goes up and reaches to a highest point. Okay, that height we have to find out. At highest point, what happens, its velocity becomes zero, but acceleration is still there, downward direction. So if someone asks you, is it possible that a body has zero velocity but constant acceleration? Yes, obviously. When a body is thrown in upward direction, then at the topmost point it has zero velocity, but downward constant acceleration is there, and that is acceleration due to gravity. Okay, 9.8 meter per second square. Clear? So in this type of 1 mark question can be asked, and you can answer it very easily. Now, suppose it is thrown and it is reaching, suppose at this side, it reaches till this side. Okay, this side we have to find out. Okay, now we can find it out in different ways, but it's better no utilize my formula which I have given earlier. V is equals to root 2 gh. Okay, now what happens here, V actually instead of V you can write here U, because we are applying this. Okay, U is equals to root 2 gh. So U is known, G is known, you have to find H. So we can square it. So U square is how much? 2 gh. Okay. Now we have to find out H. H is equals to U square by 2g. Okay. Now what is the value of U? It is 25. So 25 into 25. 2 is 2 and G is 10. Okay. Now see what we will get. This is our H. 25 into 25, 625. 625 upon 2 into 10. You will divide by 10, then decimal will come here. Okay, so you can do that very easily. 62.5 you can write by 2. Okay, now you divide by 2. So 2 3 ja 6, 2 1 ja 2.2, 2 ja 4. 4 is subtract from 5. How much left? 1. As already decimal is there, you will get 0. So it will become 10. So 2 5 ja 10. This much meter is the height it is going to achieve. 31.25 meter maximum height. Okay. Now we have to find out the time. Listen, one thing. Whatever time the body takes to go up, the same time it takes to come down. Okay. Time taken to reach to the highest point is called time of ascending. Ascending means time of climbing, because it is climbing height. No? And when it is coming down, that time is called time of descending. That is time of coming down. Okay. Both time is equal in case of gravitation chapter. Okay. Because acceleration is constant. So if you are able to find the time of ascending, time of climbing, then you can double it, you will get the total time of flight. That means total time it has taken to go to the highest point, and it has taken from highest point to come to the ground. Okay, so that part we have to do. Now for that part you can use the equation for time that you know very well. T is equals to root 2h upon g. Okay, that is the equation for time. I have already given you. Now for this I have to rub the first part. I think you have done the first part. Okay. Okay, so I'm writing this equation again. T is equal to root 2h upon g. Okay, T is there. What is H? It was 31.25. So 2 into 31.25. And G is 10. What we get? Let's see. 31.25 into 2. So 2 5 is 10, 0. 1, 2 2 is 4, 1, 5. Decimal. 2 1 is 2. 2 3 is 6. 62.50 by 10. Okay. Now, can we write it like this? See, people make the calculation sometimes very complex and difficult. But while doing the calculation, if you keep your mind open, okay, if you keep your eyes and brain both open, then what you will find, you can adjust it. How? Can you write it? 6, 2, 5. This 10 is there already, but you have removed this decimal from here. See, it is not there. So you can multiply 10 more over here. Okay. Now finding square root becomes easy. How? Square root of 625 is 25. Square root of 10 into 10 is 10. That you will get. So finally what you are getting? T is equals to 25 by 10. That is 2.5 second. Got it? So in this way we can make the calculation easy. And when you are just going and working hard only, okay, then obviously you will end up making the calculation complex. And if you suppose some minor mistake creeps in, then your answer will be wrong. Okay. So always try to be smart while calculating, smart as well as brainy. Okay. Okay. See, we have not done any numerical on that gravitation. Okay. So here is a question. See, this is the mass of the earth, this is the radius of the earth, and this is mass of the object. Okay. Earth, this is the earth, and over there this object of 2 kg is placed. Okay. We need to find out the force between them, gravitational force rather. This is the center of the earth. Okay. From center of the earth, this distance is how much? Radius of the earth, almost radius of the earth. Okay. And distance from its center to this surface of the earth, it's very small. We can take r. So total distance is r plus small r. Okay. But what happens? Small r is much less than capital R. So what we can write? This is approximately equals to a radius of the earth. Okay. Because small r is very small. So because radius of that 2 kg mass may be few centimeters. Okay. Suppose it is 5 centimeter, even 10 centimeter. No. So 10 centimeter, and here it is how much? You can see 6.4 in 10 power 6 meter. That means around 10 lakh meters. Okay. So it is much more. Okay. Now what is the expression for force? F is equals to capital G m small m upon r square. Okay. So G is how much? 6.67 into 10 raised to the power minus 11. M is how much? Mass of the earth. It is 6 into 10 raised to the power 24. 6 into 10 raised to the power 24. What is the mass of the object? It is 2 kg. So I should remove this, no? So we can write into 2 upon radius of the earth is 6.4 into 10 raised to the power 6, square of this. Now this is the force. F is equals to 6.67 into 6 to 12 into 12 upon 6.4 into 6.4. Okay, into 10 raised to the power, it is minus 11, it is 24. So plus 24 minus 11 is how much? It is plus 13. Okay, plus 13 plus, okay, plus 13 you will get. Now here after squaring, what you will get? 10 raised to the power 12. We are having here 10 raised to the power 12. Okay. Now we can take this 10 raised to the power 12 up. So what will you get? Should I rub the question now? Okay. So F will be equals to 6.67 into 12 by 6.4 into 6.4 into 10 raised to the power, it was 13 and that has come up, so minus 12. Okay, so we are going to get 10. So F is equals to 6.67 into 12 into 10 upon 6.4 into 6.4. Okay, now can we cancel this 6.4 with 12? Okay, can be cancelled by 4. 4 1 ja 4. Okay, how much is left? 2, 24. So 4 6 ja 24. So you will get 1.6. You can cancel this. 4 3 ja 12. Okay, now even we can cancel this 6.4 by 2. So we will get 3.2. Half of this, half of 6 is 3, half of 4 is 2. And this is 5. Okay, now what we have got, see, F is equals to 3 5 is 15, 6.67 into 15. And here we have to multiply 16 with 32. So 16 2 ja 32. So 2 is there, 3 is carry. Okay, 16 3 ja 48 and 3 is carry. So 48 plus 3, 49, 50, 51. Okay, decimal after one place, after one place. So total decimal after two places, that is 5.12. That's what we have got. Okay, now we can multiply this also. So what will we get? Let's see. 15 7 ja 105. So 5 is there. 10 is the carry. Okay, 15 6 ja 90. 90 plus 10, it is 100. So we get 0. 10 is carry. Okay, again 90. Okay, again 10 carry, again 100. Okay, so you have to write 100. Decimal is after two places, so decimal come over here. 100.05. Okay, here you are having 5.12. You will remove both the decimals, then what you will get? 100 0 and then 5 by 512. Okay, and now we have to divide this. Okay, okay. Dividing we get 19.5 Newton. Okay, that's what we will get. So our force is how much? It is 19.5 Newton. So Earth is attracting that object with a force of 19.5 Newton. Okay. See, this question is over with this. Let's note it down. Okay, noted. Very nice. Now see, actually, what I thought, I thought that you might be wondering when I told you in the first video that the gravitation force is a force of attraction between masses, and all the masses are attracting each other. But you might be wondering, Sir has told that all masses are attracting each other. I'm attracting the tree around me and my house and fan and the table and the chair. Then why all are not coming and getting stuck with me? Okay, or I'm not going and getting stuck with the wall or the tree or the house. What is the problem? See, this is the one part you are observing. Okay, the second part is that the earth is also pulling all of us, all the things. Okay, now which force is more? That depends. Okay, so that depends on the mass of the body. Now who has got more mass? Obviously earth. So whatever force earth is applying on all of us, all the things, okay, that is much more than force which we are applying on each other. Okay, and that's why our force is not cannot be observed, cannot be visible to us. Okay, it's similar as if suppose you have taken a bar magnet, bar magnet you know very well, and suppose you are sticking here a blade. This is a blade, suppose, and if you take another blade near to this, what you will find? It gets stuck with this. Okay, and if you are leaving this, then it will hanging here only, with this only, like this. Okay, that means this blade is attracting this. Okay, now you do another thing. You just stick this blade here, or here or here. What you will find? This blade remain here only, and this blade remain here only on the magnet. This is not magnet also. Okay, this two blades will remain at their own place. They will get stuck with the magnet, And why they are not moving to each other, towards each other? Does it mean that they are not attracting each other? Obviously they are attracting, no, we have seen earlier. But now, what about their attraction? Their attraction between them is much less than the attraction between them and a bar magnet. So the force with which the bar magnet is attracting them, that is much stronger than the force with which they are attracting each other. Okay, that's why it is not visible. Same is the case for the force between us and the force between us and the earth. Okay, so that's why our force doesn't appear, doesn't visible, we cannot see it. Okay, suppose, although this cannot happen, this is a hypothetical imaginary situation, but suppose we can think it, no, for enjoying, because physics has lots of things to enjoy. Okay, so you can just think that suppose only earth's gravitational force is switched off for a few seconds, what will happen? Just imagine. Obviously the cow will come from that side flying, okay, the snake will be flying from that side, okay, then the buffalo will coming from this side, elephant will coming from that side, okay, some house is coming from this side, okay, and some water of different color, no, different colored water is coming from different sources, and not this much only, all the animals, all the living, non-living things, trees, houses, all are coming and getting stuck together. It's so horrible, no? Thank God Earth's gravitational field is not going to switch off alone. Okay. See, already we have discussed about the value of acceleration due to gravity. But now the question arises, do the acceleration due to gravity is same throughout the surface of the earth everywhere, or is there some variation in that? So our next topic is variation. Variation in G. Okay. Variation in G. What is variation? See, first is due to first variation is due to variation in shape of the earth. Okay. What is the expression for G on the surface of earth? I think you remember. G is equals to capital G, capital M upon R square. That was the expression for acceleration due to gravity on the surface of earth. Now see, what is the structure of earth? Okay, we are talking. It is somewhat like this. You might have seen okay, different places. The earth is not perfect sphere. Okay, it is, we can say something like this. This is the polar region. This is the polar region. Okay, and here is the center. Now tell me, here this is the radius of the earth at equator, that is RE. Okay, and here this is the radius of the earth at pole, that is RP. Now which radius is less and which radius is larger? You can see RE, that is radius at equator, is greater than RP. Okay. Now what will happen? If you are going to invert this, what you will get? 1 by RE, and here we will get 1 by RP. Okay. So which will be greater? Obviously the sign will change. Why the sign will change? Let me tell you, my dear children. Let us take an example over here. You know very well 10 is greater than 2. Okay. Now if we are going to take this 1 by 10 and here 1 by 2. Now 1 by 10 is how much? It is 0.1. 1 by 2 is how much? 0.5. Now which is greater? This is greater. So after inverting, what you got? After taking a reciprocal both sides, what you got? The sign must be changed. Sign will become like this. Okay, that's what I have done here. This was greater than this, but once we have taken reciprocal, the sign will get reversed. Getting my point? Okay. Now we can square both sides. So squaring both sides, what will you get? 1 by RE square is less than 1 by RP square. Okay. Now we can multiply the same thing to both sides. If we are going to multiply the same thing both sides, what will multiply? Obviously gm. So what will get? Gm by r e square less than gm by r p square. Okay. What is this? This is value of acceleration due to gravity at equator, because here radius of equator is there. Okay, and this is the acceleration due to gravity at pole. What you will find? Acceleration due to gravity at pole is more than the acceleration due to gravity at equator. Okay, that means, so does it suddenly becomes more? No. When we move from equator to pole, the acceleration due to gravity keeps on increasing and it becomes maximum at the pole. Okay, and when you are going from pole to equator, then from pole to equator, that is from pole to equator, the acceleration due to gravity decreases and it is minimum at the equator. Okay, clear? Just note it down this. Noted? Okay, very nice. Now, what is the next thing? Let's go to the next thing. This was variation due to shape of the earth. There are some other things also. Due to depth. Okay. See, cannot write the expression for this because it is not the syllabus of this class. Although this is also not the syllabus, but I'm trying to impart you some knowledge. Okay, which you may require for NTSC or some other examinations. Okay. See, due to depth, what happens now? Suppose this is the earth. And this is the center of the earth. Okay. And you are here at a depth d, from the surface of the earth at a depth d you are there. Okay, you are there at this place. Now tell me, what is the radius of this? It is r minus d. Okay, because total radius is r, but this much is r and you have subtracted d because you reached here, so distance is r minus d. Okay, now let me tell you what is the acceleration due to gravity at this place. Okay, so acceleration due to gravity at depth d is, let us write like gd. Okay, a little better to write. So we can write gd is equals to, okay, g into 1 minus d by r. This is the expression we get actually in class 11th. Okay, so d is the depth, r is the radius of the earth. So this depth always will be less than radius. Okay, suppose you have dug a hole till half of the radius. So here what you will get? R by 2. If you are writing r by 2, so r will cancel out. You will get 1 by 2. 1 minus 1 by 2 is how much? 1 by 2 only. And 1 by 2 into g is how much? G by 2. So that means the acceleration due to gravity at depth will become, at depth half of the radius will become half of the acceleration due to gravity on the surface of earth. Okay, so that means acceleration due to gravity decreases as we go inside the earth. Okay, so write this expression, written, and draw the diagram also. Done. Okay. Then after this you will write, this indicates that, this means this expression indicates that acceleration due to gravity decreases as we go deep inside the earth. As we go deep inside the earth. Full stop. Now see what will happen at the center of the earth. When you have reached already at the center of the earth, how much depth you have covered? That is equals to radius of the earth. Okay. So what we can write? At center of earth, d is equals to how much? It is equals to r. So what we will get? GD is equals to G 1 minus R by R. R by R is how much? 1. So what you will get? G into 1 minus 1. That is G into 0. And that is 0. Okay. So acceleration due to gravity at center becomes 0. At the center of the earth becomes 0. It decreases as we go deeper inside the earth, and it becomes 0 at the center of the earth. Clear? Any doubt in this? No. Okay. Can we go for the next one? Okay. Altitude. Altitude means, suppose this is the earth, center of the earth, and we are going above the earth. Okay. Suppose we are here. The object is here. Okay. This is height h, and this is distance r. Okay. So acceleration due to gravity at altitude h above the surface of earth. From here we are measuring the altitude. Surface of earth. Okay. Is, let it be GH, because we are taking at height h. So how it is given, let me write the formula. GH is equals to, again, G into 1 minus 2h upon r. Okay. What you find here? Suppose you have gone some height. Okay. Suppose you have gone height equal to half of the radius. What will happen? You will write here r by 2 at the place of h. R by 2 when you are writing, then by 2 and this 2 will cancel out. And r will also cancel out. So you will get 1. 1 minus 1, 0. So 0 into something is 0. That means acceleration due to gravity will become 0 once you are reaching to height equal to half of the radius of the earth. Okay. Now, see, this in this written this much. Okay. Once you have written this much, just write. Drawn also. Very good. After this expression, we will write. This indicates that, this means this expression. Okay. This indicates that acceleration due to gravity decreases. Acceleration due to gravity decreases with increase in altitude. With increase in altitude. Okay. Okay. So in previous two cases we have seen that due to depth, acceleration due to gravity decreases. When we are going above the surface of the earth, again acceleration due to gravity increases. Then where the acceleration due to gravity has got the maximum value? Obviously, the acceleration due to gravity has got maximum value on the surface of the earth. Okay, so you can write down this. The acceleration due to gravity has got the maximum value on the surface of the earth. Written? Okay. Let us take one more question. Okay. See, this is a body which is being dropped from this tower. This is tower. Okay. And when it is dropped, it reaches it takes 0.6 second to reach to the ground. Okay. And acceleration due to gravity is given in the question, that is 10 meter per second square. What has been asked? Height. What is the height of this tower? That we have to find out. This height of this tower we have to find out. Okay. Time it is taking, that is given. Again we can write the formula for time. T is equals to root 2h upon g. Why I have chosen this formula? Because see, T we have to find out. T is given, h we have to find out, and g is given. So from the three quantities, 2 are known, 1 is unknown. Very easy to find out. Okay. Now we have to square this. So we'll get T square is equals to 2h upon g. So from here what we can write? Can we write h is equals to T square g upon 2. Okay, because g is divided, so it will get multiplied. 2 is multiplied, so it will get divided. What is the value of t? It is 0.6 into 0.6, because square is there, into g is 10. and here is 2. That is the value of h. Now 6 into 10, 0.6 into 10 will come 6. Okay, so we can write this 0.6 into 6.0 upon 2. Okay, clear? Because 6 into 10 60 and decimal is after one place, so this. Okay, now 6.0 means what? It is 6 only. Now it cancel by 2 3 ja, so you will get 3.0. Any problem? No. 3 6 ja 18. Okay, you can remove this decimal. This is not needed. 3.0 means 3. 3 6 ja 18. Decimal here it is not there. Here after one place. So what you will get? 1.8. 1.8 meter. That's your answer. Okay, in this way you can calculate the answer. You may use that because h you have to find out. Okay, and initial velocity when it is dropped, then initial velocity is how much? It is 0, because when you are dropping something, that velocity is 0 meter per second. Okay, so you have got u. Okay, you have got acceleration g. Okay, you have got t. Okay, you have to find out h. So you may use this formula. H is equals to ut plus half gt square. Okay, you may use this formula, but this will need lots of calculations. Okay, and this is short formula which I have given to you. Directly you can use. Okay, so any way you can use, no problem, both are correct. Okay, it depends on it varies from person to person. Okay, because perception changes from person to person. So all the things are correct once it is following the laws of nature, because physics is nothing but it's laws of nature. Okay, okay children, that's all for this video. Okay, in the next video I will come with the mass, weight, okay, difference, because you know people, most of the people, okay, they don't differentiate between mass and weight. They feel both are same. Even they are saying also that they no, both are. Suppose someone is saying you that no, both are not same, and if you ask what is different, they will not able to tell you. Okay, so I will clear this, don't worry, and then we'll go to the Kepler's laws of planetary motion. Okay, Kepler was scientist. He told how the planets used to revolve, okay, around the sun. Those things we'll get in the next video. Till then, take care, keep on studying. Bye bye.